Okay, on page 3, we have the following example. It says, hey, solve the following differential equation. You have 1 plus x dy minus y dx equal to 0. Well, the very first step is to ask ourselves, is this a separable differential equation? If yes, we need to take the integral of both sides. Okay, so let's see if we can make this into a separable differential equation. First of all, let us bring this addend to the other side. 1 plus x dy is y dx. Well, okay, how do I bring y to the other side? How do I move 1 plus x to the other side so I can make this a separable differential equation? Well, as you guessed, we're going to do a little bit of algebra. We're going to divide both sides by 1 plus x and by y. So you're going to get dy divided by y equals to dx divided by 1 plus x. Now, is this a separable differential equation? As you can see, you have dy divided by y, or 1 over y dy on one side, and dx times 1 over 1 plus x on the right-hand side. So as you can see, we have a separable differential equation. So how to solve this separable differential equation? By taking the integral of both sides. So take the integral of both sides. Okay, taking the integral of both sides, they have to do some calculus. Well, in elementary calculus, we learned that. Let's write down this recall here. If we have the integral of dx divided by x, it is equal to ln of absolute value of x plus constant of integration. And at the same time, if we have the integral of dx divided by 1 plus x, we can use substitution, which is the integral of du divided by u, which is ln of absolute value of u, which is 1 plus x plus constant of integration. Okay, so the integral on the left-hand side is going to be ln of absolute value of y, and the integral on the right-hand side is ln of absolute value of 1 plus x plus the constant of integration. We are done with the calculus part. Now we have to use algebra to write this in implicit form or explicit form. So from algebra, we know that this is ln. What is ln? It's natural log. So ln can be written as the log of absolute value of y with base e, which is equal to this expression on the other side, ln of 1 plus x plus c. So what's the meaning of that? Using the definition of natural log or just log, using the definition of log, here you have absolute value of y equals to e to this power, which is ln of absolute value of 1 plus x plus c. Now what? Well, again, I can apply algebra here. If I have exponent e to power n plus m, this is e to the n times e to the m. Very well. So absolute value of y is equal to e to power ln of 1 plus x times e to power c. But at the same time, we know that e and ln, they are inverse of each other. They cancel out each other. So what you're going to get? You're going to get, well, absolute value of y equals to, here you get absolute value of 1 plus x times e to the c. You have absolute value of y equals to absolute value of 1 plus x times a constant. What you're going to get using algebra, y is plus minus e to c times absolute value of 1 plus x. Note that plus minus e to power c is just a constant. So we're going to rename it. This is just a constant. So you can write y as, for example, k times absolute value of 1 plus c, or in general, let us use c. C times absolute value of 1 plus x. This is the family of the solutions of the differential equation. What differential equation? 1 plus x dy equals to y dx.